So let's discuss about scientific plotting, specifically in Python. Okay. So before delving into the topic, first we will look at what is scientific computation. Okay. So scientific computation may be uh, compute an expression or a result in a scientific and systematic way. Okay. Otherwise, you can able to solve, you can able to approximately solve a numerical problem or a computational intensive problem. Okay, so all these things will come under scientific computation. And also, if you want to simulate a real world issues, you're able to do scientific computation, right? So once you've done scientific computation, we'll get uh, exact results. Okay, you'll get exact results. You want to visualize it. So that process is called scientific plotting, right? So you can do in multiple ways. You can use text-based graphics or GUI. It is up to you how you want to showcase your result. It is up to you, right? Scientific plotting illustrates a phenomenon. Normally, it will illustrates what happening in your experiment, right? And also, it will help you to visualize your data. It could be your input data. It could be your output data. So through visualization, you came to know what happens in your computation, right? So uh, it is better than communication through text-based or table-based because you're communicating graphically. So this is the competitive advantage if you go for scientific plotting. It will reduce time to understand your phenomena, understand your uh, experimentation. And it is very easy to convince people if you communicate through graphics. Okay. So in this series, we're going to see about how to plot a data in Python. Fine. So we'll use most popular language Python module for plotting using matplotlib. So it is a library, and we're going to use this library to plot our scientific data. So matplotlib is the single most used Python package for 2D graphics, and also you can use for 3D graphics. Okay. It provides both a very quick way to visualize data from Python and publication quality figures in many formats. So if you are interested in publication of a journal or publication of conference paper, you need to produce a high quality output, high quality visualization, high quality image. Okay. But you can use matplotlib in order to produce very high quality scientific images. Okay, it will be scalable. Suppose if you are scaling your image, okay, the quality should not be get less. It should retain as it is whenever if you are scaling up or scaling down. Okay, so this is the package we're going to use. First we cover theoretical aspects of all these codings, then we'll go for Google Colab, how to run this code. I'll share code side by side in chat box. Okay. The most common 2D and 3D scientific plots are supported in Matplotlib. So that is why it is very popular. So it is like a package and bundle, right? So take an example of plotting functions y equal to f of x, or a simple parametric curves which requires two functions x of t and y of t. And if you want to plot discrete data, not like continuous in previous two cases, if you have discrete data, x and yi, or a complete iteration 1 to n, a limited number of series. Okay, so all these different types of data you're able to plot using Matplotlib. So where it's Matplotlib derived, it is derived from MATLAB. Okay, so MATLAB is very popular scientific software, which is very popular in scientific community. So in earlier days before Python getting popular, Matplot will solve all your kind of scientific computation or visualization. Right? So it is like a declarative way. So each and everything you need to describe. So according to your description, it will plot your data, okay, in a very beautiful, eye-catchy manner. So You can download this PyPlot. It is like a module available from Matplotlib. So each and every time you need to import from Matplotlib using PyPlot. So how to load Matplotlib package by using this three sentence. Okay, so this is the preferred way. The first one is about NumPy, numerical Python. So this package contains all your numerical computation. If you want to do matrix operations, you can easily able to do with the help of NumPy package. Okay, and we are using NumPy as NP, where NP will act like shorthand notation. So wherever if you want to use NumPy in short form, you can use NP. So in the same way, we are importing matplotlib. Okay, so matplotlib is the entire package related to plotting purpose. Specifically, if you want to import only the Python related stuff, you can use pyplot. Okay, so you can be generic in line number 2. I'll tell a simple difference. So this is about generic loading. This is about specific loading. So you can import each and every submodule specifically. So it will take very less memory space. Less memory space if you want to run. So PyPlot is especially developed for Python based, nothing else. So many modules are there. So PyPlot dedicated for Python based, somewhat faster in function. So mat function and constants are available with the numerical Python. Suppose if you want to use cos function, exponential function, or pi value, you can use prefix like np.cos. So np.cos. So this is your module. This is your module. This is your function. Okay. So this dot act like associative operator. Associative operator. Okay. So if you want to do plotting, what you can associate, you can plot with PyPlot. So we are using two main packages. One is NumPy, one is Matplot. So according to your package, you need to associate. So plt.plot means it is related to uh, Matplotlib or PyPlot, right? So if you are from non-computer science, so please bear with this terminology. Once you run this code, you try to understand. Right. The second way, most of the time, what a newbie will do, they will import each and every package belongs to PyLab, okay, PyPlot. So this is like wildcard. So this is like wildcard character, this asterisk. What it will do, it will import all sub packages. It will import all sub packages. It will consume more memory. So this method will consume more memory, where this will consume less memory because we are doing specific. Here we are importing each and everything. So it is very good practice. You need to know what you about to do in your program or plotting. You only import those packages instead of all. Okay. So this is the tip I could give. So if you want to do a plotting, what are the steps? What are the steps you need to follow? The first one is you need to import the required modules. As mentioned in previous slide, NumPy as NP or matplotlib.pyplot as PLT. So the second point is you need to load or generate some data. So this is like your input. So this is your input data. Okay. The third one is you need to optimize or customize the appearance of your figure. So this is very specific in scientific plotting. Most of the time you will use Excel, Microsoft Excel software. where it will give a very less privilege, very less functionality, you can see. So if you are using Excel, you cannot get publication level quality most of the time because it requires so much of customization in your plotting, scientific plotting. Okay, so that is why in publication house they will request plotting images which is generated by matplot. The alternative I will suggest GNU plot. GNU plot I will cover in lab part. Okay, GNU plot is a very good alternative for matplotlib. It is open source. Okay, you can use that also. Okay, the fourth step is you need to generate figure. You need to plot what you processed or what you want to visualize. Okay, so two ways you can use your visualization. Three ways. Actually, you can visualize your input data, or you can visualize how processing is get done, how processing happened. Otherwise, you can simply go for output what you got. Okay, so either you can compare with your input with your output. Okay, so straightforward this is. Otherwise, you can go staircase. You showcase your input, then showcase what happened during processing, then you showcase your output. So it is up to you. So what you want to showcase, it is up to you. Right? The last one, you can display then and there itself. So if you want to display your result for yourself to the examiner, to the supervisor, you can display on the spot, or you can save for later purpose. For later purpose, you can save in file. So what I suggest, you go for display first, then check your output. If it is suitable for storage, go for save. Right? This is for initial cases. Suppose if you are running a huge variety of experiments with different combinations, different parameter changes, then you try to save in a regular format. So use nomenclature about your experimentation setup and save in different format. Okay. So I suggest every one of you to save in SVG or PNG. PNG. So PNG put for transparency. Transparency. So it will give some transparency in your image. So it is suitable to place your image in any different kind of background. Okay. So next thing you can save in SVG, it will support vector format. Support vector format. So you will get high quality images using SVG. The publication houses, they will request most of the time either PNG or SVG format. Right. So what is the simplest kind of plot? You can use plt.plot function where you can have some x and y coordinates like 2D points. Okay. And you need to set from some ranges from 0 to n minus 1. If you want to plot like two list, you can use like f comma y. So this is the easiest way to plot. So let's check the first coding. Okay, if you want to plot a sine wave function, okay, with the help of three lines, right? Within the help of three lines. So this is the line number one. So x equal to np dot line space minus 4 multiplication. So this asterisk mentioned for multiplication operation. Okay. So np dot pi, it will return the pi value 3.14. Right? You are multiplying minus 4 into 3.14. This is what it means. Okay. What is the second parameter? You are multiplying with 4 with pi value. So how many times you are repeating this within this range? For 500 times. So this is number of times. So normally you will get 500 xy coordinates, x comma y coordinates generated by sine function. generated by sine function. You try to plot all these functions with the help of here, right? So you created value x and you are plotting against y. Okay, so x is normal. So x is normal points. Imagine 500 points. Y is sine of x. Y is sine of x. So here I mentioned wrongly. So y will store sine of x. So you try to compare these two. You try to plot x and y, x comma y, with the help of plot function. So once you run this program, run this code sniffer, you will get the output like this. So the range is from minus 4 pi to plus 4 pi. So this contains 500 points. This contains 500 points and also computed by sin x. So very easiest way to do plotting. Okay, if you use Python, within 3 lines, you able to do a plotting series. So in second example, we try to plot more than one function. Okay, with the help of 3 possibility, we'll use subplots. Right. So take an example of this code snippet. So in line number 1, what we are doing, we try to calculate 500 points. We try to store in x variable, right? So y1 we try to calculate uh, all sign value for x, all sign value for x, and y2 we try to calculate all cos value for this x, and we try to plot sine and cos function, sine and cos function. So our input series is only one. Our input series is only one. We are passing that input series for 2 different functions, and we are plotting against both of it. And look what we got. And before this, I want to mention the sine function is plotted with red color, and we are using continuous line. So this dash represents continuous line. Okay. So here we are using dot for cos function. Cos function is we are using green color. So this is how you will get uh, the continuous sine function displayed in red color. Okay, that cos function is displayed in dotted line with the help of green color. So we try to reduce the previous output. We just cover over here. Here we have multiple number of lines. Okay, we try to reduce these lines. We try to reduce these lines. And how we reduced? How we reduced? We combined xy and yy. So this entire function, whatever you got, it is stored in y1. Okay, this entire function, what it computed for cos, it is stored in y2. So we try to reduce number of lines. So it is up to you how you want to write program. So if you are writing scripts for the first time, do step by step. Once you master, try to combine number of lines and put in shorthand notation. So this is about basic plotting. This is about basic plotting, right? So what we can do with our plot, we can add a title or a legend for a better understanding about your plot. So most of the time we need to give much more detail for the audience. Okay, they able to know what your plot is about. Okay, you can give title with the help of plt.title function, and you can add legends using plt.legends, right? So once you add title and once you add legends, it will look like this. So you can add more details along with your X and Y axis. So you can pinpoint a particular location and you can give description. So this is also possible if you are using pipeline. Right. So some journals they will ask uh, from the latex format. Okay, you need to submit your subscription or manuscript to latex format where all your figures will be plotted in latex format. Okay, some journals will request. Okay, so we'll do some lab works related to plotting. So all of you go to Google Colab. All of you go to your Google Colab. All of you go to your Google Colab. Go to file. Go to file. Create new notebook. Go to file. Go to new notebook. Okay, go here. You can rename like plotting. You can rename like plotting graphs. You click over here, paste your code, paste your code. You can click this button to run your code. And you'll get output like this. We'll discuss how to adjust. I already shared code here. You please check. Are you able to run? Are you able to get the output? Okay, one more time I'll share. No issue. So always we starting with baby steps. So we are importing matplotlib. We are importing matplotlib. Okay, in the line number 1. In line number 3, we are defining coordinates. So here you can change coordinates. So instead of 2 and 3, you can give any number, right? Then what you do? You try to create a plot by using plot function. So in plot function, what you are passing? You are passing x comma y. What is the value of x comma y? It is nothing but 2 comma 3. Okay. And what is the marker? Marker will give how to display your data. So we are using like O like symbol. And what is the line style? We are using nothing because it is a single dot. So line style is none. So you can change this input value, right, according to your wish. Then what we are doing customization, how the dot need to appear. So you can mention the marker size and color, and you can see the edge color and line style, everything you can see over here, right? If you come down, if you come down, so it will give the limit axis. What is your x-axis and y-axis limit? You can change this also, right? And you can give the title. What is the label for x-axis, label for y-axis? What is the entire title for your plot? You can give. And this function will show your plot like this. Okay, so you can see what is the value of x, 2, what is the value of y, 3. Okay, we try to change this value. So instead of 2 comma 3, we give 5 comma 5. We try to change values now. Okay, we try to reduce the marker size. Now we are giving 5. Now we are changing the face color green. Okay, we keep it everything same. We try to increase the limit 10, 10, change, modify, do something, do some modification. Okay, now you simply run this code and look at the output. So this is how you can able to do customization according to your need. Are able to do so. So you're able to declare some points, you're able to plot, you can change all the parameter, how it works. Fine. So all this customization, if you want to do in Excel, it is very difficult for you. Very, very difficult for you. So whatever Excel offered, some templates you're able to use, you cannot customize as much as possible. Okay, in scientific computation, uh, each and every experiment will be unique. Okay, will be unique. So that is why I prefer every one of you to go through Matplotlib or using GNU plot. So one more thing I want to mention, you can go for GNU plot, which is similar for Matplotlib, but having more extension. So this is very good resource if you want to try with the different tools. So go to this page and you can work on. So next we'll see a different example, right? How to plot a line. Again, this is very, very simple for you. I'll share this code. So what we are doing here, we are using NumPy package. So this is numerical Python. We are giving shorthand notation like NP. So wherever NP appears, the implicit meaning is NumPy. Okay. So look at line number 4. What we are doing, we are calculating an array 1 to 8. So the value is 1 to 8. In line number 5, we are calculating the value from 3 to 10. We try to plot 1 comma 8 to 3 comma 10. So these two are our xy coordinates. And we try to plot x points and y points. So this is like this. So what is the range given for x? Starting from 1. Okay, what is the range given for x until 8? We can see from 1 to 18 x-axis. And what is the range we given for y? 3, 10. So see the range of y-axis 3, 10. Are you able to get this one? What do you do? Try to give some title for this x-axis, y-axis. Try to modify. Okay, programming is always relevant how much you practice, not about the learning, how much you practice. The more you practice, the more the expertise you will get. So next what we do, we try to plot a curvature. So this is the straight line. This is a little bit curvature. This is exponential curve, right? I try to share this code. Try to run this code. So look at the line. Look at the line. What we are doing, we are generating a number with the help of a range function. So it will start from 0.0. Okay. So what is the sample size? 5. And until what range it will go for 0.2. So this will create a number of points. It will store under T. Okay. And we are plotting the T and we are doing all computation over here. We are plotting T. Okay. We are plotting with red color line and we are plotting T square. So maybe I'll mention. So this is about normal T. Normal T. This will plot T square. This will plot T cube. Okay. You can see the difference over here. So one is straight line, plotting the T itself. One is doing square. This blue color is displaying square. This green color is T cube. So R stands for red color. You can see. Okay. BS stands for this blue color. And G stands for green. And this dash represents dotted line. Okay. This S stands for square. Okay. This this cap symbol represents triangle. Are you able to get the output? Okay, great, great. So come down. Now we try to plot sine axis, sorry, sine function. So try to run this code. So what we discussed in theory, we able to do here. So we generated 500 points using line space. Okay, L in space. Okay, we are storing in variable x and we are passing that x to sine function. So sine function will compute sine value for all 500 points and it will store in y and we are plotting x against y. So x-axis contains 500 points. Okay, y-axis contains the equivalent cost value for 500 points. So next what we do, next we try to compare sine function and cos function with the different colors. So look at here, what we are doing like the previous program, but here we are computing two different functions. So y1 holds sine value, y2 holds cos value, and we are plotting these two with different color notation. So R stands for red, hyphen stands for dotted line, G stands for green, and this colon stands for solid dotted line. Sorry. So this hyphen stands for solid line. Able to get the output? I will share. Don't worry. Then what we do? We try to plot multiple functions. So this is multiplot. Right? So if you go for journal, you need to save space. You need to showcase most of the information within small space. Okay. So if you want to compare also, this is very useful. Okay. So you plotted two functions in the same diagram. You plotted two plots in the same diagram. So this is called multiplot. Fine. Then what we do? We try to plot histogram. All these codings are self-explanatory, so no need to worry about coding. If you're looking at it, within 1 or 2 days, you're able to understand what it means. So try to change values over here, then you will be able to know what is the data given, how you can modify. I try to change the last value. Right. So what code I shared is different. What I modified here is different. So try to modify your code, then you're able to know how it works. Okay. So next we try to plot in a pie chart. Okay, this is very simple example. So I will share code to you. You try to run, try to modify code, then run. So we gave 4 labels and we gave 4 size. So accordingly it will plot. So if you want to plot in Excel, you need to do a lot of stuff. Here it is dead easy. I will share study material. I will share this i.p1b file in Canvas. Don't worry about that. Okay. If it is possible, you try to run here itself. Next, we go back to PowerPoint. So let me know whether my slide is changing. The title is classical algorithm. Now we're going to cover about algorithm part. Okay. Is my slide changing about algorithm? I'll share in Canvas. Don't worry. Let's discuss what is an algorithm. a process or set of rules to be followed in calculation or other problem solving operations, especially by a computer. So algorithm is step-by-step process. Okay, step-by-step process. So if you want to compare algorithm in other synonyms, it is like procedure, or you can say rule book, or you can say protocol, or if you are comparing with cooking, it is like recipe. Okay, or you can say it is like a manual, how you going to do. So it is like step by step, right? If you are writing a program, the program need to be get operated in step by step operations. Where this algorithm came from, it came from the word from 9th century mathematician, okay, Muhammad ibn Musa al Khawarizmi. So, sorry for my pronunciation. In Latinist terms, it is called as algorithm. Okay, so most of the algebra and algorithm came from Persian background or Arab background. Okay, uh, if you want to say in equivalent terms in computer science, so algorithm is like a generic. So most of the time you can say in mathematical form, or you can say theoretical form algorithm, where program is indicated for a computer. So what you write in algorithm, you can convert as a program. So this is what it means. Okay. So program is set of series of coded software instruction to control the operation of a computer or other machine. So by writing program, what you are able to do, you are able to control the hardware, whatever available in your laptop or system, right? So initially we will write algorithm. Okay, based upon the algorithm, we able to convert as a program or coding. So most of the time, what user will think, we will write straight away the coding part. That is not good practice. Most of the time, we need to understand the problem. We need to well state that problem. If you are stating a problem in well versed manner, then most of the time it is half solved. Okay. So this is quoted by Charles Kettering. Okay. So this code is great. So it implies for each and every one of us. And this is very famous quote by Albert Einstein. So if I had an hour to solve a problem, I'll spend 55 minutes thinking about that problem and 5 minutes thinking about the solution. So most of the time, we need to spend about thinking about that problem. What is the given problem, and what is the nature? What are the constraints involved? Okay, what are the real implication we need to think about in that perspective? The more we are thinking about that problem, the more efficiently we are able to create solutions. Right. So most of the time in software, people will think they will directly go for coding. Coding is very fractional part about solving a problem. Right. So this is the basic flow. You have some input, and algorithm will come in middle. It is set of rules of obtain expected output from the given input. You will do some processing and you will get output. So this is the basic flow. First, we need to understand what is a problem. A problem can be defined as a real world problem or a real world instance problem, for which you need to develop a program or set of instruction, and obviously an algorithm is set of instruction. So each and every time you need to give instruction. Okay. So you have a set of instruction, then you can call it as a algorithm. Right. So algorithm is step-by-step process designed for the problem. So actually the algorithm is intended to solve this problem. Right. So to do this, you need to identify inputs. So the first process is you need to identify inputs, right? Once you identified inputs, you need to decide the data type. You need to decide the data type. Once you identify the data type, you can store efficient data structure. So most of the time, the data structure depends upon your hardware architecture. Okay, everything is dependent, right? So once you need to understand your problem, once you understand, you can convert into algorithm in a solvable way. Then you need to identify the inputs required for your algorithm, right? Then you need to do computation. So the computation will come here. The computation part will come here. Okay. The input will be passed to the processing unit. Normally it will be your CPU. It will produce the desired output. So here you will get the different output. What you got is actual output and desired output. So if your algorithm is crystal clear, if it is clear, okay, if it is logically correct, then only able to get the desired output. So if you are doing any mistakes, okay, you won't get desired output. You won't get desired output. The output is the outcome or result of the program, which is referred to as an output. Okay. So what are the steps involved in program development? The first one is problem definition. The second one is algorithm design. The third one is pseudo code. The fourth one is actual code. Right? We will discuss the steps one by one. The problem definition is clearly articulate the problem and its requirements. Okay, you can describe in normal English statement. Okay, what is your problem? So in software development, the software architect, he will go to visit the client and he will discuss about the problem. He will write in clear statements. Okay, what is their problem? What they want to solve? What is their requirement? They need to do several meetings. Okay, so once they got a requirement from clients, they will go for algorithm design. So once they know how to solve it, they will devise a step-by-step solution to solve that problem. Again, this is very generic, like in English statements. English statement. So once you design the algorithm, then you can go for pseudocode. So pseudo stands for not original. Okay, pseudo is not original, and it represents the algorithm in high level language agnostic form. So this is before the programming language. It is not in original programming. Okay, this is very generic. Again, this is very generic. Like a mathematical uh, theorem. Okay, you need to describe with generic language. Once you have all these three steps, okay, then you can go for actual coding. Okay, if fresher directly go for coding, will miss most of the logics. If you go directly, if you go coding directly, coding part directly, you will do lot of mistakes, lots of mistakes. Okay. The choice of algorithm depends upon the specific problem and its constraints. So each and every problem, okay, is very entirely different and it contains so many different constraints. So you need to understand all these parameters, then only you need to decide the solution. There will be multiple solutions available for the same problem, right? And each and every solution will approach in different ways. And you need to benchmark all these solutions to select the most suitable solution. Okay, what you need to do, a problem will contain so many specifications, specifications. Okay, and it contains so many constraints. You need to go through all this stuff. Okay, and it will give multiple solutions. So solution 1, solution 2, and solution 3, you will get multiple solutions, multiple ways to solve that problem. Okay, what you need to do, you need to compare all these solutions using benchmark. You need to run using different solution, and you need to compare against them. Then only you can pick which is the most suitable solution or efficient solution. So this is the trick, and it will take lot of time. Even for the experienced programmer or developer, they cannot identify at a single shot. Okay? When designing algorithm, what you're supposed to do, you need to break problem into smaller or manageable tasks. It will simplify the structure, and it will allow you to program process more intuitively and scalably. So most of the time in software, what they will do, they will break problem into smaller chunks. Okay, until it is manageable level. So programming is not just about solving problem. It is about finding the most elegant, efficient part to your solution. So if you are doing this, be able to achieve, then only you could be a good programmer. Good programmer. Okay. So actually, programming is very little part. Most of the time, you need to analyze. You need to devise different solutions. So how do algorithm works? Again, like we previously discussed, contains input, processing, output, and we need to measure the efficiency. Finally, we need to do optimization. So we'll discuss all these topics with the help of coding. Right. Finally, we about to implement. Once you got optimized solution, you can go for implementation. Then only your business will survive. Okay. The input, the algorithm will take input in various forms. It could be numbers, it could be text, it could be images, it could be any format. Okay. So once you have input, then you can go for processing. Once you have solution, you can go for processing. Most of the time, you will do logical and mathematical operation over your data. By doing so, you are manipulating your data. You are manipulating, you are transforming. Okay. So once you do all these steps, you'll get desired output. Okay. With the help of output, what you can do, you can take a decision. So this is why we are using computers. Okay. So this decision should be based upon informed data. Okay. Informed data or authentic data. Then only you're able to get meaningful information. If you're taking input like garbage, which is unauthorized, if you're doing some solution without benchmarking, then you won't get desired output. Okay. The fourth point is about efficiency. A key aspect of algorithms is about all their efficiency, aiming to accomplish the task quickly with minimal resource. So most of the technological giants like Google, Microsoft, or IBM, okay, they're known for their algorithmic efficiency. Because of this, they're able to conquer the market. Take an example of Amazon. Amazon have a very well-structured, scalable cloud computing framework when compared to any other organization. So each organization accomplished their market share by their algorithmic efficiency. Okay. Once they got efficiency, they need to optimize more and more. So algorithmic designer constantly they will seek ways to optimize their algorithm, making them faster and more reliable. So most of the software company they will do rigorously to retain their market share. Okay. So each and every term you can compare to a real world entity and you try to relate, and all these topics seems to be very meaningful, even though it is more and more theoretical. Okay. So once you got all this stuff, then you can go for implementation. Okay. So for during implementation, you can choose variety of languages suitable for your problem, suitable for your application. So pseudocode is like a false way to describe. Okay, it is like a natural English statement. It is not actual code, but it will act like a blueprint how you are about to write your code. Okay, before going for programming, you can go for pseudocode. It will give a better understanding about the problem. And pseudocode is a simplified representation of program's logic. So it will be available in both mixture of natural language and programming language elements. So it will come intermediate. Okay. So it is not executable, but it will help you to give a better comprehension, and it will enhance collaboration among developers. So if there are multiple developers, multiple language they need to develop, so it will act like a collaborative platform, right? If you are using pseudocode. So for an example, if you want to calculate the height of a fallen tree by using trigonometry, okay, so you can do using a pseudocode. To take an example of a tree breaks at a point and forms a 30-degree inclination angle to a ground. So take an example. So this is your tree. So this is your ground. Okay. Suppose if tree breaks at point, and it forms 30-degree angle. It forms 30-degree angle, right, with the ground. On top of the tree touches ground at 10-meter distance. Suppose if this top of the tree touches from this point to 10 meters from the base of the tree, then how will you calculate the height of a fallen tree? So this is our goal, right? So what we do normally, mathematical approach will use trigonometry principles. Okay, the height of the broken point and length of the fallen tree part can be calculated using this formula. So base equal to 10 meter, angle equal to 30. So we'll use tan theta to calculate base height to the base ratio, and cos theta to base to the hypotenuse. And height of the breaking point can be calculated using base multiplied with tan, and length of the fallen part can be calculated base to the cos theta. So this is the mathematical approach by using formulas. If you're writing through a pseudocode, you'll describe any English statement with the mixture of both mathematics. Okay. So please go through this slide. So line number 1, we are starting. So this is the starting part of your algorithm. Starting part of your algorithm. And this is ending part of your algorithm. Ending part of your algorithm. So everything in computers should be deterministic. So that is why we are mentioning where we are starting, where we are stopping. Okay. So what is the input given? Distance from the root. So look at your code. The distance given is base equal to 10 meter. The next one is angle about 30 degree. And what we need to calculate? We need to calculate original height of the tree. What you require? You require pi value. You require pi value. So this is additional. This you need to identify. Okay. So what you need to do? You need to define the angle in the terms of pi. Okay. We are converting the degree into radian. We are converting the degree into radian. So this is computation. This line is an computation. The line number 6 also computation. What you are doing, you are calculating the distance from the root to cos. So whatever the angle given, you convert it into radian, and that radian is given for cos function. So this will give the broken part length. Line number 5, line number 6, as well as line number 7 is computation part. We are calculating the broken point height. Then we are calculating the original tree height. So likewise, we are doing step by step. So once you got the output, you can display over line number 9. So here no computation. So line number 9 is not about computation. So here you are not doing any computation. Here you are not doing any computation. Only line number 5 to 8 we are doing computation. So you need to know what you are doing in your algorithm and which line will get executed in your system. So once you have algorithm, if you are running any solution, okay, any coding, you need to benchmark. So what is the meaning of benchmark? You need to benchmark the runtime in Python, any language, involve measuring the execution time of your code snippet or function. So it is like a time clock, okay, from starting time to ending time, how much time it consumed, you able to know. Okay, for that we need to use timeit module, which is predefined module available in Python, commonly used for this purpose. It will provide a way to accurately measure a small code fragments. Okay, it will support only small code fragments, right? Then what we can do, it will mitigates the impact of system fluctuations by running the code multiple times and calculate the average execution times. Because your computer or laptop is a simple device, okay, it won't work in the same way each and every time. So small fluctuation may be there during execution time. So in order to calculate the average, you need to do multiple times and you need to measure the time each and every occurrence. Okay, so if you do so, to benchmark code using timeit, one can use the command line interface or the module function within a Python script. So first I will explain the theoretical part, then I will share the coding part to try to execute. For an example, to measure the time taken to sum of first 10 lakh numbers, okay, you need to execute this line in your command prompt. So Python -m, okay, timeit is the function and this is the command, it will execute. So this is the code actually. This is the code. You can run this code in your command prompt. So I will share this code with you. I am switching from PowerPoint to coding. So check chat box. Is my screen visible to you? Google Colab.
Yes, sir, it is visible, sir.
Great, sir. Great. So try to run this code. What we are doing, we are importing time library, time module. Okay, line number 2. We try to record the starting time of your execution. So line number 4 will start. Line number 1, 3, 5 are commands. So this won't execute. So line number 1, 3, 5 are commands. So these lines are non-executable. So you no need to bother about these lines. So this will give guidelines for user or reader. Okay, this will give more information. So without these lines also you are able to execute. So what I do, I try to delete. You can reduce number of lines. Even though if you have 1000 lines of command, okay, it won't impact your execution time because it won't execute. Okay, so line number 2, we start to record the time. If you are giving time. Okay, so this will take your system time. So if you are looking at downside, the time is 3:14. Okay, from this time stamp it is recorded to this start variable. Next we are giving a equal to 0. Okay, then we are doing a for loop. So for loop is a iterative statement. For I in range 1000, a plus equal to I into 100. So we are multiplying a for 100 times. Okay, we are doing some computation and we are adding back to a. And we try to record the ending time after this for loop. Okay, so what we try to record, the time taken from line number 3 to line number 6. So we try to calculate time of this code, this part of code, this part of code. So part by part, you're able to do this. Okay. So in line number 10, what we are doing, we try to print the execution of above program in terms of milliseconds. So it will take 0.96 milliseconds. So it will differ from system to system. So that is why. So if you're using a laptop, if you're using CPU, if you're using server, this time will differ for the same code. Is it clear? Shall we move? Great. So come down. Here we try to calculate between the iterations. Here we try to do calculation with different iterations. Okay, so generally it will increase the time complexity. So each number of time, it will record and it will display. So instead of a single range, we are giving multiple range, and each and every range we try to print that timestamp. So try to run this code. You will get timestamp according to the given range. Fine, you can see how much time taken for first 100, it will take 0.069. How much time taken for 200, it will take for 0.151. So by doing this, you able to know if any fluctuation is happening, whether your algorithm or program executing in a synchronized way, or you can see any malfunctions or delay in execution, you able to know all this stuff. So it will give a time complexity analysis about your algorithm performance. So next what we do, we try to use different time functions, okay, using date time module in Python. Here we are using date time dot now. So it will record timestamp of start and end instance and find the difference to get code execution time. So in multiple ways, in different ways, you're able to do the time calculation. So this is alternative method. I'll share this code with you. So try to execute this code. And you see the time of execution of above program is 1.624 milliseconds. So it will find the difference between the starting of your loop and end time. It is about your system time, not about your CPU time. It will take timestamp from your system, not from CPU. Then you can do in multiple ways. I will show that time it function. Okay, this is very simple example, right? If you want to identify how many times, how much time a simple Python expression took, it returns the total time for entire execution. So this is very simple code. Import time it, okay, call time it dot time it, and you are doing 2 to the power 1000. So it will calculate 2 to the power 1000. Okay, how much time it took. It will say how many number of seconds for entire computation. Okay, you can use keywords argument to specify the code and number of iteration also. If you're doing little modification in your function. So this is your code. This is your Python code. Python code, or you can say you want to do some computation, and you are passing that computation as an argument, and you are giving number of iterations. So play with this, try to run with a different code, different algorithm, be able to know how it is working. Now I am running, I got 0.72. Let's see, little bit variation is there, right? Now I got 0.73. So each time fluctuation will happen in your computation and processing. So that is why you got little difference. Suppose if you want to evaluate more code, then you can easily fit within the statement string by defining a function. So what we did in previous slide, we simply give a statement, okay? But if your code is much more complex, you can define a separate function for it. Okay? So let us discuss about this function. So we are defining f of n. So this is the function definition. This is your function definition. Okay. Next, we are using assert keyword. So this will use to debug. So this will use to debug. It will use to check conditions before running your code. Okay. So what is the given condition? Assert n should be greater than 6. Otherwise, it will throw error and it will identify some mishappening in your code. So it will alert you. Right. So you can put condition like this. Right. So I will put line number 1, 2, 3, 4, 5, 6, 7, and 8. Great. So what we are doing in line number 3, we are creating a empty list. Okay, line number 4, we are creating a range of number. So whatever the input is given, so here user need to give input. Here user need to give input. Need to give input. Okay, so this input is given for this range function, and it will create a list. It will create a list. Okay, we don't know how many elements are there in the list. Suppose if you are giving input as 8, what it will do, it will create a range of 8 variables. Your list size will be 1 to 8. So this is the meaning. Suppose if you are giving 9, your list size will be 9. Okay, so it will do append. Append means update. Each and every time it will update. So append is nothing but update. Fine. So what it will do? 1, 2, 3, 4, 5, 6, 7, 8. It will update 8 numbers because it is in range. Okay. So on line number 6, again it will do a range 1 to 10. 1 to 10. Okay. So this is dynamic. This input n is dynamic. This input 10 is static because it is already determined. Already determined in your program. So each and every time it will take the list, it will do append, and it will do slicing. Okay. So this is about your coding. Fine. So let's see how much time it will take. If f is an inefficient nonsense function that creates a list and append to itself, slice it, and repeats 10 times. Look at your code. So each and every time what it will do, it will append. Okay. It will append to itself and it will slice. So it will do the repetitive process. Okay. Sometimes it will append, sometimes it will slice, and it will repeat for 10 times. Okay. And we need to use global keyword to allow time it to use your local definition. Take an example of count equal to 1000, time it statement f of 10, and do for number of count, whatever the number you are giving, it will do for 1000 times, and it will do global call. Let's see how it is working. So this is the function definition I shared. And this is about calculating time in between your function call. So first you need to execute this function definition. Then you need to execute this time it function. So it is very easiest way. No need to put the difficult coding like previous stuff. Okay. So you can create a function. Like here we need to mention the starting time and ending time, right? If you have multiple function, very difficult to do benchmarking. Where in this case, simply pass that function to this command. Now you can benchmark multiple function, multiple algorithm, then you can compare, then you can able to identify which solution is efficient or which function is efficient. Are able to run? Because we are giving some condition, because problem contains some constraints, right? So we are putting some constraints. Here the constraint is 5. So suppose if you are giving less than 6, this code will get impact. Your processing will get impact. That is why. Next, what we can do, by default, Python turns off garbage collection within the timing, but you can enable it. Okay. So Java have garbage collection as well as Python have garbage collection. Okay. So it will manage your memory in efficient way, right? So for this, you need to use GC library, the import GC, and you pass this GC in this statement called setup. So how you are enabling this GC garbage collection using setup equal to gc.enable. By default, it will in turn off mode. Okay, but you can switch it on by enabling using setup keyword. So this is very important feature. If you are worrying about memory management, you can enable it. So it will take care. Your software will take care. I will describe what is garbage management. Suppose if you are giving int a, okay, if you are declaring, so this is your RAM. This is your RAM. So here it will allocate memory space. It will allocate memory space. Memory space. Suppose if you execute all your code, okay, you entered your coding, you are entered your execution. Still it will be stored in your memory. Still it will be stored in your memory. So this is garbage for your memory, because the purpose is solved. You computed something, but still it will remain in your RAM. It will occupy unnecessary memory space. Okay. Suppose if your language is Java, suppose if your language is Python, okay. So these two will take care about these variables. So it will check whether the life cycle of this variable is there. Okay. If it is accomplished, it will remove from your memory. So this will be taken care by garbage management. So it will manage memory instead of a developer. So actually developer need to erase all these variables. They need to free up. Okay. So instead of that, we can give control to the software or language. It will do for you. Is it clear? So sometimes if you're testing your code, okay, so if you're turning garbage collection on or off, it may increase your execution time or it may decrease your execution time, depends upon how you're testing. Depends upon how you're testing. It is up to the user. User can enable it or user can disable it. But what I suggest, you enable it and check how much time it will take. Disable it, how much time it will check, and you can see how efficiently your language is doing garbage collection. Suppose if your algorithm taking less memory space, no need to enable. If it is taking so much of memory space, then please enable it. Then what you can do? Then what you can do, instead of using garbage collection, okay, sometimes it will increase the time of execution, but you can reuse if it is already available in your memory. So if your variable is stayed in your RAM, okay, use it as much as possible instead of recomputing each and every time. So this is what I suggest. Okay, so in this all this way, you able to devise your algorithm. Okay, you able to do execution, you able to timestamp. Once you timestamp, enable the garbage collection. Okay, compare all this value, then you come to a conclusion which solution is fast and efficient. So multiple ways you can do. Okay, you need to decide. You need to explore. For the same problem, there will be multiple solution exist, and pick which solution take less memory space, less time duration. So I want to mention the repository of plotting, Matplotlib. Matplot, if you simply Google Matplot examples, you'll reach here where you can have a variety of examples. I'll share this link with you. Please go. So today, please go to this link, and we have ample of example. Nearly 420 examples are given. Right. So I took some example from this website. So suppose if you want to do plotting categorical variable, they gave code. What do you do? Just copy over here. Copy. Go to your Google Colab. Click code. Okay, paste over here. Try to run. So easily able to do plotting. Then you can rename the variables. You can change the ranges. Okay. Then you can modify whatever you want. So they gave so many different varieties, bar chart with labels, right? So within the single bar, you're able to compare two or more categorical data and variables. Okay. Suppose if you are dealing with physics and chemistry, you can do cross-spectral density. If you're dealing with communication, so you can plot all your signals, all your signals. So this is about scatter plot, most famous plot. So if you have different kind of data, you can able to display in scattered way about the distribution, how it is distributed among the range. And a line plot is very famous. Everybody use line plot. We already discussed about generating sine wave. Okay. And here I want to mention, if you want to save your data, you can save .png, .svg. So this code I will share with you. Okay. Go and execute. So go here, create new code, paste over here, try to run. And you see the graph is generated, not only generated, the file is created under the name this.png. To look at this, click this folder, you see this.png. Download. So whatever you plotted, be able to save as a file with publication quality. Most of the time we'll struggle to generate output images. Yeah, you can use any Visual Studio. You need to ensure you installed Python as well as Matplotlib library, because most of the user, they are using Google Colab. That is why I chose. It is up to you. You can rotate your image. You can scale it. You can scale up. So little image processing also you are able to do. You can transform your image. Okay. So that is why these packages give a complete degree of freedom for you. Suppose if your image or data are not fixed, you can display in little slanted way. Instead of coding, I'll share link. Please go to this link and check by yourself. See, sometimes your data won't fit in your plot. Sometimes you need slanted representation. So it is like reverse engineering. You directly go to the template, okay, run that code, try to modify according to your need. So your learning time will get reduced so much if using this matplotlib library functions or examples. Suppose if you are working in mathematical background, if you are dealing with statistics, okay, so this package will help you to plot all kind of statistical plots. Where you can have different kind of plots, box plot, right? Violin plot. So each and every plot has some meaning. So according to your output, you need to pick your plot. Go through all this stuff and try to understand what is the use of that plot. Okay, if it is suitable for your research, go with it. Histogram, all of us know, right? So in this way, you are able to do histogram. Suppose if you are dealing with time series data, if you are using for healthcare applications, or if you are using for stock market, okay, you can go for line plot, time series histogram. And this is about pie chart. I already covered about pie chart. And this is about polar axis. You are able to see what is the distribution among all these ranges. Okay. So every plot covers a different perspective about your output or about your data. Suppose if you want to do a 3D model, okay, where I saw 3D printing. So you can plot a 2D data on 3D plot. So this is how it will appears. So it will give a more detailed perspective about your data if you go for 3D. So according to you, you need to pick which is more suitable to convince your audience. Okay. Same way you can go for 3D bar charts. So it will give more implication about your output. So the same output is generated in different ways. One is 2D, one is 3D. Where 3D give more insights or more in-depth details how it is distributed. In same way, you can display 2D images in 3-dimensional view, right? So you can combine all 2D images and you can give a 3D aspects. So that's all about Matplotlib. So if you want to explore GNU plot, we'll cover what is GNU plot will offer. This is almost more powerful when compared to Matplot. Why it is? Okay. Sorry about that. Not available. But this is very good tool. Yes, plot info. Thank you. Maybe IP restriction for me. Sorry about that. It will work for you. Early it came. Yeah, I checked. So that's all about today's session. All right. So learning plotting is somewhat interesting when compared to programming because you will visualize your output as soon as possible. Already all videos are posted on YouTube live link. You can be able to check it. In your canvas also it is displaying. I will put all your materials, all these coding part, interactive Python, everything to you. Thank you all. I will send all reference books, all links in the PPT. You please check it. I'll share.